Hello, bored people, and welcome back to Muted History. Before we dive in, take a moment to settle wherever you are, whether you're scrolling through your phone at 2 a.m., taking a break from work, or just looking for something that won't assault your brain with flashy graphics and shouting. You're in the right place. This isn't going to be one of those frantic history videos. No dramatic music, no clickbait thumbnails promising to blow your mind. Just the quiet, strange story of humanity told at a pace that actually lets you think. If you find this kind of content useful, whether it helps you focus, sleep, or just escape the noise for a while, consider hitting that like button. It tells the algorithm that maybe, just maybe, thoughtful content deserves a spot in your feed too. And if you're new here, subscribe for more stories from the forgotten corners of human history. Now let's begin. Today's story is about failure. Not the kind you'd expect from a history channel, but a different kind entirely. It's about the migrations that didn't make it, the expansions that fizzled out, the early humans who walked incredible distances only to vanish without leaving descendants. For the better part of 150,000 years, our species tried repeatedly to leave Africa and establish themselves elsewhere. And for most of that time, they failed. This isn't the triumphant tale of human expansion you might know. That story, the one where modern humans spread across the globe around 60,000 years ago and never looked back, is real. But it wasn't the first attempt. It wasn't even the second or third. Before that successful wave, there were others. Pioneers who crossed deserts, climbed mountains, and sailed across straits, only to disappear from the archaeological record as quietly as they had appeared. What makes their story so compelling isn't just the mystery of where they went, but what it tells us about the nature of human expansion itself. These weren't random wanderings or accidental migrations. These were deliberate movements by anatomically modern humans who had the same brains, the same basic toolkit, and likely the same curiosities as the ancestors who would eventually succeed. Yet somehow, they vanished. The earliest evidence of these failed migrations comes from some unexpected places. In a cave in southern Greece, researchers found a skull fragment that shouldn't exist. Not because it's impossible, but because according to our traditional timeline, modern humans weren't supposed to be in Europe 200,000 years ago. The fragment, known as Apidema 1, has all the hallmarks of Homo Sapiens anatomy. A rounded skull, modern proportions, none of the heavy brow ridges or elongated features of Neanderthals. Yet there it was, preserved in limestone, tens of thousands of years before we thought our species had left Africa. What's even stranger is that this early human presence didn't last. The same cave system that preserved evidence of these ancient sapiens later became home to Neanderthals. It's as if two different species took turns using the same shelter. Separated by thousands of years, neither aware that others like them had been there before. This pattern repeats across the archaeological record. In Israel, at a site called Mislia Cave, excavators found a jawbone and teeth that clearly belonged to modern humans. The surrounding sediments date to nearly 180,000 years ago, making this one of the earliest confirmed presence of our species outside Africa. The cave shows signs of repeated use, with carefully maintained hearths and tool-making areas. These weren't just passing travellers. They had established themselves, created a home, developed routines, and then, like the humans in Greece, they disappeared. The tools they left behind tell a story of competence and planning. Flint had been shaped using sophisticated techniques that required genuine skill and teaching. Fires had been maintained in the same locations over extended periods. Someone had even created what appears to be bedding from plant materials, carefully arranged near the warmth of the hearth. These were people who understood their environment and had adapted to it successfully. Yet their descendants are nowhere to be found in the genetic record of modern populations. Moving east, the mystery deepens. In the deserts of Saudi Arabia, at a site called Al-Wusta, researchers discovered something that seemed impossible at first glance: a single finger bone, curved and delicate, belonging unmistakably to a modern human. But this finger wasn't found in isolation. It was surrounded by the fossilized remains of hippos, elephants, and other large mammals, typically associated with African savannas. The sediments told the story of an ancient lake, fed by monsoons that no longer reach this part of the world. The dating was startling. This finger, this single piece of evidence for human presence, was nearly 90,000 years old. It represented a time when what is now one of the most inhospitable deserts on Earth was actually a green corridor, dotted with freshwater lakes and teeming with wildlife. Early humans hadn't just reached this oasis, they had lived there long enough to hunt the local fauna and leave behind stone tools. But like the others, these Arabian pioneers left no lasting legacy. When the climate shifted and the monsoons retreated, the lakes dried up and the grasslands turned to sand. The corridor that had enabled their expansion became a barrier that cut them off from their origins. Whatever happened to them, whether they retreated, adapted, or simply died out, they contributed nothing to the gene pool of living humans. Even more intriguing are the hints from Asia. In caves scattered across southern China, researchers have found human teeth that date to over 100,000 years ago. These aren't the robust molars of earlier human species, but the smaller, more gracile teeth characteristic of modern humans. Yet they appear without context, without the rich archaeological signatures we'd expect from sustained human occupation. No tools, no hearths, no clear evidence of how these people lived or what they ate. The teeth seem to represent another wave of early expansion, possibly following coastal routes that are now underwater due to rising sea levels. These humans may have island-hopped their way across Southeast Asia, taking advantage of lower sea levels that exposed land bridges and shortened ocean crossings. But like their contemporaries elsewhere, they left no descendants and no clear cultural continuity with later populations. What's particularly striking about all these early migrations is how they seem to follow environmental opportunities. The humans in Arabia appeared during a period when orbital cycles brought increased rainfall to the peninsula. The expansion into Europe coincided with warmer interglacial periods when forests extended further north. The movement into Asia may have been facilitated by coastal environments, rich in marine resources. This suggests that early human expansion wasn't driven by some inherent wanderlust or superior technology. Instead, it was opportunistic, following ecological windows that opened and closed based on climate cycles. When conditions were favourable, small groups of humans would venture into new territories. When the climate shifted, those same territories could become uninhabitable, cutting off the pioneers from their source populations and condemning them to isolation. The scale of these failed expansions is difficult to grasp. We're not talking about a few individuals who wandered too far from home. Genetic evidence suggests that some of these early migrations involve substantial populations that established themselves successfully for thousands of years. They weren't evolutionary dead ends or primitive proto-humans struggling to survive. They were us, anatomically and likely behaviourally, just separated from us by time and circumstance. Perhaps most remarkably, some of these early humans left genetic traces not in our lineage, but in others. Ancient DNA recovered from Neanderthal and Denisovan fossils shows clear evidence of interbreeding with early modern humans. Not the later populations that would eventually spread across the globe, but earlier waves that have no direct descendants today. Their genes survive only as fragments in the genomes of other human species, a ghostly reminder of meetings between different kinds of humans in landscapes that no longer exist. This genetic evidence reveals something profound about the nature of human expansion in deep time. The boundaries between different human populations weren't as clear-cut as we often imagine. Early modern humans didn't simply replace other species through superior technology or intelligence. Instead, they met, mingled, and sometimes merged with other human lineages in ways that blur the lines between replacement and integration. The story of these failed migrations challenges many of our assumptions about human exceptionalism. If early modern humans were essentially identical to us in terms of anatomy and basic capabilities, why did they repeatedly fail to establish lasting populations outside Africa? The answer seems to lie not in their limitations, but in the inherent difficulty of successful expansion under Pleistocene conditions. Small founder populations are vulnerable to demographic accidents that have nothing to do with adaptive fitness. A single bad season, a disease outbreak, or a shift in predator populations could eliminate an entire group. Without the ability to receive reinforcements from source populations, isolated communities faced extinction probabilities that increased with every generation. Climate instability made these challenges even more severe. The Pleistocene was characterized by rapid oscillations between glacial and interglacial conditions. Environments that had supported human populations for millennia could become uninhabitable within centuries. Migration corridors could close, cutting off retreat routes and leaving populations stranded in increasingly hostile landscapes. The archaeological record bears witness to this environmental volatility. Sites that show evidence of sustained human occupation are often followed by long periods of abandonment. Tools and hearths disappear from the stratigraphic sequence, suggesting that entire regions became depopulated during adverse climatic phases. When humans return to these areas, they often bring different technologies and cultural practices, suggesting that the newcomers had no connection to earlier inhabitants. This pattern of expansion, abandonment, and recolonization appears to have continued for over 100,000 years. Wave after wave of early humans ventured out of Africa, established temporary footholds in new territories, and then vanished from the record. Each failure was followed eventually by new attempts, as if our species was slowly learning through trial and error how to survive in unfamiliar environments. The cumulative effect of these failed expansions may have been more important than any individual success or failure. Each wave of migrants carried with them the accumulated knowledge of their predecessors. Each failure taught lessons that could be passed on to subsequent generations. The eventual successful expansion around 60,000 years ago may have benefited from this long history of experimentation and adaptation. But that success story is for another time. What matters now is understanding that human expansion was never inevitable or straightforward. It was a process filled with false starts, dead ends, and quiet disappearances. For every population that established itself successfully, there were likely many others that tried and failed. The humans who vanished from Greek caves, Arabian oases, and Chinese hills weren't inferior to those who eventually succeeded. They were pioneers, pushing the boundaries of what was possible for our species under the challenging conditions of the Pleistocene world. Their failures weren't signs of weakness, but evidence of the extraordinary difficulty of successful expansion in a world without agriculture, permanent settlements, or the demographic buffers that come with large, stable populations. Their story continues to unfold as researchers develop new techniques for detecting ancient human presence and extracting genetic information from increasingly degraded samples. Each new discovery adds another piece to the puzzle of early human expansion, revealing a process far more complex and contingent than we ever imagined. In our next part, we'll explore how these early migrations finally began to succeed and what changed in human behavior and organization that made permanent expansion possible. But for now, it's worth reflecting on these vanished pioneers and what their story tells us about the precarious nature of human survival in deep time. The failures weren't random, though. When you look at the timing of these vanished migrations, a pattern emerges. They cluster around specific periods when the Earth's climate was shifting, when ancient corridors were opening and closing like geological doors. Understanding this timing helps explain not just when these early humans moved, but why they moved when they did, and perhaps more importantly, why they couldn't stay. The Earth's climate during the Pleistocene wasn't just cold or warm in simple terms. It oscillated dramatically between what scientists call glacial and interglacial periods, driven by subtle changes in our planet's orbit around the Sun. These orbital cycles, known as Milankovitch cycles, affected how much sunlight reached different parts of the Earth at different times of year. The result was a climate that swung between extremes over tens of thousands of years, creating windows of opportunity that opened and closed with astronomical precision. During warmer interglacial periods, the African monsoons strengthened and pushed further north, bringing life-giving rains to regions that are now desert. The Sahara, that vast barrier we think of today, periodically transformed into a green corridor dotted with lakes and rivers. Archaeological evidence suggests that during these wet phases, human populations expanded northward through what is now Libya, Algeria, and Morocco, following game animals and seasonal resources toward the Mediterranean. But these green Sahara periods were temporary, lasting only a few thousand years before the orbital cycles shifted again. As the monsoons retreated, the grasslands dried up, the lakes evaporated, and the corridor became a trap. Human populations that had ventured into these northern territories found themselves cut off from their source populations in sub-Saharan Africa. Some may have retreated south before it was too late. Others became stranded in an increasingly hostile landscape. The archaeological record from these periods is frustratingly sparse, partly because desert environments are harsh preservers of organic remains, but occasionally tantalizing glimpses survive. In the Egyptian Western Desert, researchers have found stone tool scatters dating to around 130,000 years ago, during one of these wet phases. The tools show sophisticated napping techniques and suggest organized hunting activities around what were once permanent water sources. More dramatic evidence comes from the central Sahara, where ancient lake beds preserve the fossilized remains of crocodiles, hippos, and fish alongside human artifacts. These weren't brief visits by nomadic hunters. The density and distribution of tools suggest sustained occupation over centuries or millennia. These were communities that had successfully adapted to a Saharan environment that was fundamentally different from today's desert. Yet when the climate shifted and the rains failed, these communities vanished. No genetic traces link them to later populations. No cultural traditions survived the transition back to desert conditions. They represent entire chapters of human history that were written and then erased by forces beyond their control. Similar patterns played out in other regions. The Levant, that narrow corridor between Africa and Eurasia, experienced its own cycles of habitability. During warm periods, Mediterranean forests extended inland, creating a mosaic of woodlands and grasslands rich in game and plant foods. Archaeological sites like Skul and Kafze in Israel show evidence of early modern human occupation during these favourable phases, complete with sophisticated burial practices and symbolic artifacts. But the Levant was also subject to climatic instability. When global temperatures dropped during glacial periods, the forests retreated and the region became more arid. The same caves that had sheltered early modern humans were later occupied by Neanderthals, who were better adapted to the cooler, drier conditions. The archaeological sequence at these sites reads like a story of successive occupations by different human species, each taking advantage of environmental conditions that favoured their particular adaptations. The timing of these occupations reveals something crucial about the nature of early human expansion. It wasn't a steady progression of increasingly successful adaptations. Instead, it was opportunistic, following environmental windows that opened and closed based on factors completely beyond human control. Early modern humans weren't failing because they lacked intelligence or technology. They were succeeding temporarily and then being overwhelmed by environmental changes that made their territories uninhabitable. This environmental determinism extended far beyond Africa and the Mediterranean. In Arabia, the same orbital cycles that brought monsoons to the Sahara also affected rainfall patterns across the peninsula. During wet phases, the interior of Arabia supported grasslands and permanent lakes. Rivers flowed where today there is only sand. Elephants and hippos grazed where now only camels can survive. The Al-Wusta site, with its isolated fingerbone, represents one of these green Arabia phases. The sediments tell a story of a landscape that would be unrecognizable today. Freshwater mollusks indicate permanent lakes. Pollen grains reveal grasslands, dotted with acacia trees. Animal bones show a fauna typical of East African savannas. This wasn't a marginal environment where humans struggled to survive. It was, for a time, a continuation of the African ecosystem that had shaped our species. But like the green Sahara, green Arabia was temporary. As orbital cycles shifted, the monsoons weakened and retreated. The lakes dried up, the grasslands withered, and the peninsula returned to desert. Any human populations that had established themselves during the wet phase would have faced a stark choice: retreat to more favourable areas or adapt to increasingly arid conditions. The archaeological record suggests that most chose retreat if they had the option. Stone tool traditions that appear during wet phases disappear from the record as conditions deteriorated. There's no evidence of gradual adaptation to drier conditions. No slow transition from lake-based to desert-adapted lifestyles. Instead, there's simply absence, as if entire populations packed up and left when the writing was on the wall. But retreat wasn't always possible. As climate zones shifted, migration corridors could close faster than populations could respond. A group that had spent generations adapting to lakeside environments might find their retreat route blocked by expanding deserts. Rivers that had provided navigation aids during the expansion phase might dry up, leaving no clear path back to more favourable areas. The demographic mathematics of small populations made these environmental pressures even more deadly. A band of 50 humans might be perfectly viable during good times, but if environmental stress reduced their reproductive success even slightly, they could spiral toward extinction within a few generations. There was no buffer of surplus population to absorb losses, no network of neighbouring communities to provide assistance during difficult times. Genetic studies of modern populations provide indirect evidence of these ancient demographic crashes. The relatively low genetic diversity of humans outside Africa suggests that successful expansions were founded by small groups that went through severe population bottlenecks. But for every founder population that survived these bottlenecks, there were likely many others that didn't. The successful expansions we can trace genetically represent the survivors of a much larger process of expansion and extinction. This pattern of environmental opportunity, followed by environmental constraint, wasn't limited to arid regions. In Southeast Asia, sea level changes created and destroyed land bridges that connected islands to the mainland. During glacial periods, when much of the world's water was locked up in ice sheets, sea levels dropped by over 100 meters. Vast areas of what is now ocean floor were exposed as dry land, creating continuous territories from mainland Asia all the way to New Guinea and Australia. Archaeological evidence suggests that early modern humans took advantage of these land bridges to reach islands Southeast Asia much earlier than previously thought. Sites in Sumatra and Borneo have yielded human teeth and tools dating to over 70,000 years ago, during a period when these islands were connected to the Asian mainland. But when the ice sheets melted and sea levels rose again, these land bridges were submerged, potentially cutting off island populations from their source communities. The fate of these early island colonists remains unclear. Some may have adapted to maritime lifestyles, becoming the ancestors of later island populations. Others may have been overwhelmed by rising seas and tropical diseases. The archaeological record is too sparse to provide definitive answers, but the pattern fits the broader theme of expansion followed by isolation and potential extinction. Even more intriguing is evidence from Australia, which was never connected to other land masses even during the lowest sea levels. Reaching Australia required deliberate sea crossings, probably using rafts or simple boats. The earliest definitive evidence for human presence in Australia dates to around 50,000 years ago, but there are hints of even earlier occupation. If humans were crossing open water to reach Australia over 50,000 years ago, they were clearly capable of more sophisticated planning and technology than is often assumed for this period. But the same capabilities that allowed them to reach isolated continents may have made them vulnerable to environmental changes that disrupted their maritime adaptations. The story becomes even more complex when we consider the role of volcanic eruptions in disrupting these early expansions. Around 74,000 years ago, Mount Toba in Sumatra erupted with unprecedented violence, ejecting so much ash and sulfur into the atmosphere that it temporarily altered global climate. The eruption blanketed much of South and Southeast Asia in a thick layer of volcanic ash, destroying vegetation and potentially causing widespread famine. Some researchers have argued that the Toba eruption caused a severe population bottleneck in early human populations, reducing the entire species to a few thousand individuals. While this extreme scenario is debated, there's no question that the eruption would have had devastating effects on any human populations living in the affected regions. Communities that had successfully established themselves across Southeast Asia could have been wiped out in a matter of years. Yet, archaeological evidence from sites like Jwalapuram in India suggests that some human populations survived the Toba eruption. Stone tools appear both below and above the volcanic ash layers, indicating continuity of occupation through this catastrophic period. But survival doesn't mean that these populations thrived or expanded. They may have been reduced to small, isolated groups struggling to maintain themselves in a dramatically altered landscape. The cumulative effect of these environmental pressures was to make successful expansion extremely difficult during the Middle Pleistocene. Even populations that initially succeeded in new territories faced constant threats from climate change, volcanic eruptions, and demographic accidents. The marvel isn't that so many early expansions failed, but that any succeeded at all. This environmental context helps explain why the eventual successful expansion around 60,000 years ago was so different from earlier attempts. By this time, human populations had developed more sophisticated technologies and social organizations that made them more resilient to environmental stress. They had learned to create demographic buffers through larger group sizes and intergroup networks. They had developed symbolic systems that allowed for more efficient transfer of knowledge and coordination of activities. Most importantly, they had learned to adapt more rapidly to environmental change. Instead of depending on stable environmental conditions, they had developed the flexibility to exploit a wider range of resources and respond more quickly to shifting circumstances. This wasn't just technological advancement, but a fundamental change in how human societies organized themselves and related to their environments. But we're getting ahead of ourselves. The story of how humans finally developed these capabilities is complex and still poorly understood. What's clear is that it built on the accumulated experience of earlier failures. Each failed expansion had taught lessons about the challenges of survival in unfamiliar environments. Each environmental crisis had selected for populations with greater resilience and adaptability. The humans who eventually succeeded weren't necessarily smarter or more capable than those who had failed before them. They were the beneficiaries of a long process of cultural and technological accumulation that had been building for over 100,000 years. Their success was possible only because of the failures that had come before, failures that had slowly pushed human societies toward greater complexity and resilience. In our continuing exploration of these vanished migrations, we'll delve deeper into the specific mechanisms that made survival so difficult for early human populations outside Africa. We'll examine how demographic accidents could doom even successful communities, and how the absence of agricultural buffers made every environmental stress potentially fatal. The story of human expansion is ultimately a story about learning to survive in an unpredictable world, and understanding the failures is crucial to understanding the eventual success. The challenges facing these early human populations extended far beyond simple environmental pressures. Even when climate conditions were favourable and resources abundant, the mathematics of small population survival worked against long-term success. Demographics, it turns out, can be as unforgiving as drought or volcanic ash. Consider what happens when a founding population of perhaps 30 to 50 individuals establishes itself in a new territory. In good times, such a group might seem perfectly viable. They hunt successfully, gather plant foods, raise children, and maintain their cultural knowledge. But demographic stability in small populations is an illusion. Every birth, death, and reproductive decision echoes through the entire community with amplified consequences. The problem begins with simple probability. In any given generation, roughly half the children born will be male and half female. But in small populations, random variation can skew these ratios dramatically. A founding group might produce mostly males for several generations, creating a shortage of reproductive females that dooms future population growth. Alternatively, a run of mostly female births might seem advantageous, but without sufficient males, the population faces different but equally serious challenges. Even more critical is the age structure of small populations. Adults die from accidents, diseases, predation, and the simple wear of Stone Age life. In large populations, these losses are absorbed easily. But when your entire community consists of 47 people, the death of even a few key individuals can be catastrophic. Lose the only person who knows how to make fire in wet conditions, and the whole group might perish during the next storm. Lose the most experienced hunter during a difficult season, and everyone goes hungry. The archaeological record hints at these demographic disasters through its silences. Sites that show evidence of sustained occupation for centuries sometimes end abruptly, with no signs of violence or environmental catastrophe. Tool traditions simply stop appearing in the sediment layers. Hearths go cold and are never relit. The simplest explanation is often demographic collapse, a community that shrank below the minimum viable size and couldn't recover. Genetic diversity presents another trap for small populations. Close relatives are forced to interbreed, leading to reduced fertility and increased susceptibility to diseases. Children born from these unions might appear healthy initially, but often carry hidden genetic burdens that become apparent only in subsequent generations. Over time, the entire population becomes increasingly fragile, less able to cope with environmental stresses that their ancestors might have weathered easily. Modern studies of isolated human populations provide sobering examples of how quickly genetic diversity can erode. The Amish communities of Pennsylvania, despite starting with several hundred founders, show measurable effects of genetic bottlenecks after only a few centuries. Imagine the challenges facing Stone Age populations with far smaller founding groups and no possibility of genetic rescue from outside communities. The cultural implications of small population size were equally severe. Human societies depend on the accumulation and transmission of knowledge across generations. Complex skills like advanced toolmaking, seasonal navigation, or medicinal plant use require dedicated specialists who can focus on mastering these abilities. But in a community of 40 people, everyone must be a generalist. There's no room for the deep specialization that allows knowledge to accumulate and improve over time. This creates what researchers call a cultural ratchet effect. Instead of steadily accumulating knowledge and skills, small populations tend to lose them. Each generation might fail to fully master all the techniques passed down by their parents. Gradually, the community becomes less capable, not through lack of intelligence, but through the simple mathematics of knowledge transmission in small groups. Archaeological evidence for this cultural degradation is subtle but present. Stone tool assemblages from isolated sites sometimes show decreasing sophistication over time. Early layers contain elegant, carefully crafted implements that required considerable skill to produce. Later layers from the same sites show cruder, less sophisticated tools that accomplish the same basic functions, but with less finesse. This isn't evidence of declining intelligence, but of communities struggling to maintain their full range of cultural knowledge. The problem becomes acute during crises. When environmental conditions deteriorate, small populations face a cruel dilemma. They need their most sophisticated survival skills precisely when they're least able to maintain them. Harsh conditions force everyone to focus on immediate survival, leaving no time for the careful teaching and practice that complex skills require. Knowledge that took generations to develop can be lost in a single bad decade. Language itself becomes vulnerable in small populations. Complex languages require diverse social interactions to maintain their full vocabulary and grammatical structures. Children learning language in very small communities might not encounter the full range of linguistic situations that their parents navigated easily. Over generations, languages can become simpler, losing subtle distinctions and specialized terminology that might be crucial for survival in specific situations. These linguistic changes leave traces in the archaeological record through their absence. Sites occupied by early human populations often lack the diversity of specialized tools that we'd expect from communities with rich technical vocabularies. Without precise words for different types of stone, various hunting techniques, or subtle environmental conditions, knowledge becomes harder to preserve and transmit accurately. The social dynamics of small populations created additional vulnerabilities. In larger societies, conflicts between individuals can be managed through various mechanisms: physical separation, mediation by neutral parties, or simply the dilution effect of having many other relationships to focus on. But in a group of 30 people, every interpersonal conflict becomes a community crisis. A serious dispute between two key members can split the entire population, potentially dooming both factions. Archaeological sites sometimes preserve evidence of these social fractures. Tool traditions that had been consistent for centuries might suddenly diverge, with some hearths showing one style of stone working, while others show completely different approaches. This suggests communities that had split apart, with different factions developing their own ways of doing things. In large populations, such cultural diversity might be beneficial. In small isolated groups, it often signals the beginning of the end. Marriage patterns in small populations created particularly complex challenges. Most human societies have incest taboos that prevent marriage between close relatives. These taboos serve important biological functions, but they also create social problems when your entire community consists of a few extended families. Young adults might find no acceptable marriage partners within their group, forcing them to remain single or leave to find partners elsewhere. When individuals leave small communities to find mates, they rarely return. The knowledge and skills they carry with them are lost forever to their birth community. Over time, this brain drain can hollow out a population's cultural capabilities. The most capable and adventurous individuals are precisely those most likely to leave. gradually reducing the community's overall competence and resilience. Some populations might have tried to solve this problem by maintaining contact with other human groups, exchanging marriage partners, and sharing knowledge, but such networks require careful maintenance and are vulnerable to environmental disruptions. When climate changes make travel dangerous or impossible, isolated communities lose these crucial connections and face demographic collapse. The seasonal nature of many resources added another layer of complexity to small population survival. Many Stone Age communities depended on resources that were available only at specific times of year. Salmon runs, fruit ripening, animal migrations. Successfully exploiting these resources required precise timing and coordinated group effort, but small populations have little margin for error. If key individuals become sick or injured at crucial moments, the entire community might miss essential harvesting opportunities. Archaeological evidence suggests that many early human populations lived extremely close to the edge of subsistence. Bone chemistry studies show that even successful communities often experienced periods of nutritional stress. During good years, they might accumulate small surpluses, but bad years could quickly exhaust these reserves, leaving no buffer against further difficulties. The absence of storage technologies made these challenges even more severe. Unlike later agricultural societies, which could preserve large quantities of grain for years, early human populations had limited ability to store food for extended periods. Most preservation techniques available to Stone Age peoples, drying, smoking, fermentation, could extend food storage from days to months, but rarely to years. This meant that every community was perpetually vulnerable to multi-year environmental fluctuations. Predation added yet another threat to small human populations. Large carnivores, cave lions, saber-toothed cats, giant bears were common throughout much Pleistocene whirl of Thed. A healthy adult human was rarely easy prey for such predators, but children, elderly individuals, and anyone weakened by injury or illness were vulnerable. In large populations, predation losses could be absorbed. In small groups, the loss of even one or two individuals to predators could trigger demographic collapse. The psychological stresses of living in small isolated populations should not be underestimated. Humans are fundamentally social creatures who suffer measurable health consequences from isolation and loneliness. Communities that became cut off from other human contact would have experienced increasing psychological stress as generations passed. Depression, anxiety, and social dysfunction can become epidemic in isolated populations, further reducing reproductive success and survival rates. Modern studies of isolated communities show that psychological health often deteriorates before physical health, creating a cascade of problems that can doom even otherwise viable populations. People stop taking care of themselves and their children. They lose motivation to maintain their tools and shelters. They make increasingly poor decisions about resource management and risk-taking. These psychological factors rarely leave direct archaeological evidence, but their effects would have been devastating for small Stone Age populations. The cumulative effect of all these demographic pressures was to create what scientists call an extinction vortex. Small populations face multiple simultaneous stresses: environmental, genetic, cultural, social, psychological. Each stress makes the population smaller and less resilient, which increases the severity of all the other stresses. Once this process begins, it becomes extremely difficult to reverse. Archaeological sites around the world preserve evidence of communities that seem to have been caught in such extinction vortices. Occupation layers become thinner and less dense over time, suggesting shrinking populations. Tool assemblages become simpler and less diverse, indicating cultural loss. Finally, human presence disappears entirely from the archaeological record, sometimes for thousands of years, until new populations arrive with no apparent connection to their predecessors. Understanding these demographic traps helps explain why early human expansion was so difficult and why so many apparently successful populations vanished without descendants. It wasn't enough to reach new territories and establish initial settlements. Long-term survival required maintaining populations large enough to weather the inevitable demographic storms that small groups faced. This was an almost impossible challenge, given the technologies and social organizations available to early humans. The populations that eventually succeeded in establishing permanent presences outside Africa were those that somehow solved these demographic problems. They developed larger founding populations, maintained connections with source communities, created social mechanisms for managing conflicts, and evolved cultural practices that preserved knowledge more effectively. But these solutions took time to develop and were built on the accumulated experience of countless earlier failures. The vanished migrations we've been exploring weren't just unlucky victims of environmental change. They were testing grounds for solutions to fundamental problems of human expansion. Each failure provided data points about what worked and what didn't under various conditions. Each extinct population contributed to a species-wide learning process that eventually made successful expansion possible. This perspective transforms our understanding of these early human movements, from tragic failures to essential experiments. The humans who died out in Greek caves, Arabian oases, and Asian forests weren't evolutionary dead ends. They were pioneers whose experiences, filtered through whatever knowledge survived their disappearance, helped later populations avoid the same mistakes. Their legacy lives not in their genes, which are lost forever, but in the hard-won wisdom that eventually enabled our species to spread successfully across the globe. Every stable human population today exists because earlier populations learned, through trial and error, how to survive the demographic challenges that had doomed their predecessors. But demographic collapse was only one of the mechanisms that could erase early human populations from the archaeological record. Environmental change, as we've seen, could make entire regions uninhabitable within decades or centuries. Volcanic eruptions could destroy ecosystems across continents. Even successful adaptations could become liabilities when conditions shifted rapidly enough. The interplay between these different extinction mechanisms created a complex landscape of survival and failure that shaped human evolution in ways we're only beginning to understand. Each population that vanished represented not just a demographic loss, but the elimination of unique cultural adaptations and genetic variations that might have proved valuable under different circumstances. In examining these lost experiments in human survival, we begin to appreciate just how contingent our own existence really is. The successful expansion of modern humans around 60,000 years ago wasn't inevitable or predetermined. It was the culmination of a long process of trial and error that consumed countless earlier populations in its slow approach toward viable solutions. Human adaptability during the Pleistocene wasn't just about developing better tools or larger brains. It was about learning to maintain viable populations under conditions that seemed designed to drive small groups toward extinction. The solutions that eventually emerged were as much social and demographic as they were technological, representing new ways of organizing human societies that could survive the demographic storms that had destroyed their predecessors. These organizational innovations didn't appear suddenly or universally. They emerged gradually, tested constantly by the harsh realities of small population survival. Many promising developments were lost along with the populations that carried them. Others survived and spread, becoming part of the cultural foundation that made later expansion possible. The story of these vanished migrations is ultimately a story about resilience and the price of learning to survive in an unpredictable world. Every successful human population today carries the accumulated wisdom of countless earlier failures, demographic lessons learned through the disappearance of entire communities. Our existence is built on the foundations of their vanished experiments in human survival. The story becomes even more haunting when we examine what happened during the periods between these failed migrations. While scattered groups of modern humans were vanishing from caves in Greece and lake shores in Arabia, something equally significant was occurring back in Africa. The continent wasn't simply a launching pad for doomed expeditions. It was a dynamic laboratory where human populations were regrouping, innovating, and perhaps most importantly, learning from the failures of those who'd ventured out before them. Between roughly 100,000 and 60,000 years ago, as external migrations repeatedly collapsed, Africa itself underwent a remarkable transformation. Archaeological sites across the continent show evidence of increasing cultural complexity during this exact period. Not the explosive, symbolic revolution that would come later, but something subtler and perhaps more significant: the slow accumulation of survival strategies that would eventually make permanent expansion possible. In the caves of South Africa, sites like Blombos and Sibidu preserve evidence of innovations that seem almost mundane until you consider their implications. Compound adhesives, made by combining tree resins with other materials, allowed for more sophisticated tool hafting. Heat treatment of stone improved the quality and predictability of knapping. Bone tools became more common and more specialized. None of these developments were revolutionary on their own, but together they represent a growing mastery of material culture. More intriguingly, these innovations appear simultaneously across sites separated by thousands of kilometers. The same hafting techniques show up in coastal South Africa and highland Ethiopia. Similar heat treatment methods appear in East Africa and the Kalahari. This suggests something unprecedented: the maintenance of cultural networks across vast distances, allowing innovations to spread between populations that might never have met directly. These networks become even more significant when you consider what was happening to human populations during this period. Genetic studies suggest that African populations went through their own series of expansions and contractions, driven by the same climate cycles that were trapping migrants in distant lands. But instead of simply collapsing when conditions deteriorated, these populations developed strategies for maintaining connections even during difficult periods. The evidence is subtle but persistent. Stone tools show up far from their source materials, suggesting long-distance transport or exchange networks. Coastal populations show evidence of inland resources in their middens, while highland sites contain marine shells. Most tellingly, genetic diversity within Africa increased during this period, not decreased. Populations were mixing and exchanging genes across previously isolated regions. This internal expansion and connection within Africa may have been the crucial difference that eventually made external expansion successful. Instead of small isolated founder populations venturing into unknown territories with limited cultural knowledge, the later successful expansions involved groups that carried the accumulated wisdom of an entire continent. They weren't just anatomically modern humans, they were culturally connected humans. The timing of this internal African renaissance corresponds precisely with the failure of external migrations. As groups in Arabia faced desiccation, as populations in the Levant were replaced by Neanderthals, as island colonists in Southeast Asia vanished from the archaeological record, their African contemporaries were developing increasingly sophisticated strategies for survival under harsh conditions. Some of these strategies were technological. The projectile weapons that would later prove so crucial for hunting in unfamiliar territories first appeared in African sites during this period. Microliths, those tiny stone blades that could be combined into composite tools, became increasingly common and standardized. But the most important innovations may have been social and demographic. Evidence from multiple sites suggests that human groups were learning to maintain larger population sizes during good periods and to network more effectively during difficult ones. Instead of fragmenting into isolated bands when resources became scarce, they developed mechanisms for sharing information and resources across wider areas. When local environments deteriorated, populations could shift without losing cultural continuity. This represents a fundamental change in how human societies organize themselves in response to environmental stress. Earlier populations seem to have responded to difficulties by becoming more insular, focusing resources on core group members and reducing contact with outsiders. But the African populations of this period did the opposite. They responded to stress by increasing connectivity, sharing risks across larger networks, and maintaining cultural exchange even when direct contact was difficult. The archaeological evidence for these networks is necessarily indirect. We see it in the distribution of raw materials, the spread of technological innovations, and the maintenance of genetic diversity across vast distances. But the implications are profound. By the time the next major expansion attempt began, around 60,000 years ago, African populations had developed social technologies that made them fundamentally more resilient than their predecessors. These social innovations didn't emerge in isolation. They built on the accumulated experience of earlier failures, both internal and external. Each collapsed population had provided data points about what worked and what didn't under various conditions. Each environmental crisis had tested different survival strategies. The populations that survived carried forward not just their own successful adaptations, but lessons learned from observing the failures of others. This learning process was facilitated by the very connectivity that made later expansion possible. Information about failed migrations could travel back through trade networks and marriage exchanges. Stories of abandoned settlements could be preserved in oral traditions. Knowledge about environmental changes in distant regions could inform local decision-making. The African populations of this period weren't just developing better survival strategies, they were developing better ways of learning from failure. The role of climate change in driving this internal African evolution cannot be overstated. The same orbital cycles that opened and closed migration corridors also created periods of environmental stress within Africa itself. Populations that had previously lived in isolation were forced to interact as their territories shifted. Groups that had relied on single resources were compelled to diversify. Communities that had been stable for millennia suddenly faced the need to adapt or disappear. But unlike their contemporaries in Greece, Arabia, and Asia, African populations had access to demographic and cultural buffers that made survival possible. When one region became uninhabitable, people could retreat to more favorable areas without losing contact with their cultural networks. When traditional resources failed, alternative strategies developed elsewhere could be quickly adopted. When populations shrank below viable levels, they could merge with neighbours without losing their essential cultural knowledge. This buffering effect explains why genetic diversity within Africa increased during this period, while diversity outside Africa remained limited to small, ultimately unsuccessful founder populations. African populations were learning to survive demographic bottlenecks through cultural rather than genetic adaptation. They were developing social mechanisms that could preserve essential knowledge even when communities were reduced to minimal sizes. The innovations that emerged from this process weren't just technological improvements. They represented new ways of thinking about human society and its relationship to environmental change. Instead of viewing population growth as simply beneficial, African societies learned to maintain sustainable population levels that could be supported during difficult periods. Instead of maximizing short-term resource extraction, they developed strategies that preserved long-term ecological stability. These cultural adaptations left subtle but persistent traces in the archaeological record. Sites show evidence of more careful resource management, with animal bones indicating selective hunting that maintained prey populations rather than exhausting them. Plant remains suggest diversified gathering strategies that reduced pressure on any single resource. Most importantly, occupation patterns show greater flexibility, with sites being abandoned and reoccupied in response to environmental changes rather than being occupied continuously until collapse. The psychological dimensions of these social innovations may have been even more important than their practical benefits. Learning to survive in small isolated populations requires not just technical skills, but mental resilience. The ability to maintain hope and social cohesion during extended periods of hardship becomes crucial for long-term survival. African populations during this period seem to have developed cultural practices that supported psychological as well as physical survival. Evidence for these psychological adaptations appears in the gradual increase of symbolic artifacts during this period. Not the explosion of cave art and elaborate ornaments that would come later, but subtler markers of social identity and group cohesion. Ochre use becomes more systematic and widespread. Shell beads appear more frequently in sites far from any ocean. Stone tools begin to show regional stylistic preferences that serve no obvious functional purpose. These symbolic markers suggest populations that were consciously maintaining cultural identities even under stress. Instead of abandoning non-essential activities when resources became scarce, they preserved the social practices that held communities together. This represents a sophisticated understanding of what was actually essential for long-term survival. Not just calories and shelter, but the social bonds that made cooperation possible under difficult conditions. The contrast with failed external populations becomes stark when viewed from this perspective. Archaeological sites outside Africa from this period show little evidence of symbolic activity or social elaboration. Tool assemblages are purely functional. Settlement patterns suggest small groups focused entirely on immediate survival. There's no indication of the social investments that might have helped these populations weather demographic storms or environmental crises. This suggests that successful expansion required not just the ability to reach new territories, but the social technologies necessary to maintain viable populations once there. The African populations that eventually succeeded in permanent expansion carried with them not just better tools or larger founding groups, but fundamentally different approaches to social organization that had been tested and refined through millennia of internal expansion and contraction. The transition from failed to successful expansion wasn't marked by any single technological breakthrough or environmental change. Instead, it represented the culmination of a long process of social and cultural evolution that had been occurring within Africa throughout the period of external failures. By the time conditions again became favorable for expansion around 60,000 years ago, African populations had developed the cultural toolkit necessary for permanent settlement in unfamiliar territories. This toolkit included not just improved hunting and gathering techniques, but social mechanisms for maintaining larger populations, cultural practices that preserved essential knowledge during crises, and psychological strategies that supported group cohesion under stress. Most importantly, it included networks of information exchange that allowed successful innovations to spread rapidly between populations. The archaeological record shows these networks in action during the period immediately preceding successful expansion. Technological innovations that appear in one region of Africa quickly spread to distant areas. Cultural practices become increasingly standardized across vast distances. Population movements, tracked through genetic markers, show increasing connectivity between previously isolated regions. By 60,000 years ago, Africa wasn't just the source of anatomically modern humans. It had become a continent-wide laboratory for developing the social technologies necessary for human expansion under Pleistocene conditions. The populations that finally succeeded in permanent settlement outside Africa weren't just biologically modern, They were culturally equipped with survival strategies that had been tested and refined through thousands of years of demographic experimentation. This internal African renaissance transforms our understanding of why earlier expansions failed and later ones succeeded. It wasn't simply a matter of reaching some threshold of technological sophistication or encountering more favorable environmental conditions. It was about developing social organizations that could maintain viable populations under the challenging conditions that had doomed earlier attempts. The failed migrations we've been exploring weren't just unlucky victims of environmental change or demographic accidents. They were part of a species-wide learning process that eventually produced the cultural innovations necessary for successful expansion. Their failures provided essential data points about what didn't work under various conditions. Their disappearance freed up ecological niches that would later be filled by better adapted populations. But perhaps most importantly, their stories, filtered through whatever communication networks existed between populations, contributed to the accumulation of knowledge that made later success possible. The humans who eventually spread across the globe weren't smarter or more capable than those who had failed before them. They were the beneficiaries of a long process of cultural evolution that had been built on the accumulated experience of countless earlier experiments. The demographic innovations that emerged from this process weren't just abstract social technologies. They had concrete implications for how expanding populations organized themselves and responded to challenges. Instead of fragmenting into smaller groups when facing difficulties, they learned to maintain larger, more resilient social units. Instead of relying on individual expertise, they developed systems for preserving and transmitting knowledge that could survive the loss of key individuals. These organizational changes are visible in the archaeological record through subtle but persistent patterns. Sites associated with successful expansions show evidence of larger group sizes, more systematic resource exploitation, and greater cultural continuity over time. Tool assemblages become more standardized, suggesting shared learning systems that could preserve technical knowledge across generations. Settlement patterns show greater flexibility and responsiveness to environmental change. Most significantly, the successful expansion populations show evidence of maintaining cultural connections across vast distances. Similar artifact styles appear simultaneously in regions separated by thousands of kilometers. Raw materials are transported much further than would be necessary for purely local needs. Genetic markers indicate ongoing gene flow between populations that had supposedly separated centuries earlier. This connectivity was the crucial innovation that separated successful from failed expansions. Earlier populations had ventured into unknown territories as isolated pioneers, cut off from their source communities and dependent entirely on their own resources. The later successful populations maintained umbilical connections to the African cultural networks that had produced them. They weren't just colonizing new territories, they were extending existing social systems into new environments. The implications of this connectivity extended far beyond simple resource sharing or information exchange. It provided psychological anchoring that may have been crucial for maintaining group cohesion under stress. Populations facing difficulties in new territories knew they weren't alone in the world. They carried with them not just tools and techniques, but cultural identities that connected them to larger human networks. This psychological dimension of successful expansion has been largely invisible to archaeological investigation, but its importance can hardly be overstated. The mental health challenges facing isolated populations are severe and cumulative. Communities cut off from larger social networks often experience increasing rates of depression, anxiety, and social dysfunction that can doom them even when their material needs are met. The successful expansion populations avoided this trap through cultural practices that maintained psychological connections to home communities even across vast distances. The evidence for these psychological adaptations appears indirectly through the persistence of non-functional cultural practices in new territories. Successful expansion populations continue to produce symbolic artifacts, maintain ritual practices, and preserve cultural knowledge that serve no obvious survival purpose in their new environments. This suggests communities that were consciously maintaining cultural identities rather than simply focusing on immediate survival. These cultural investments required resources that earlier populations might have devoted entirely to subsistence activities. But they provided psychological benefits that may have been crucial for long-term survival. Populations that maintained rich cultural lives were more resilient to the stresses of life in unfamiliar territories. They were more likely to preserve the social cohesion necessary for collective decision-making and mutual support during crises. The archaeological signature of this cultural resilience appears in the continuity of artifact traditions across time and space. Successful expansion populations didn't abandon their cultural practices when facing difficulties. Instead, they adapted these practices to new circumstances while preserving their essential characteristics. This represents a sophisticated approach to cultural change that balanced adaptation with continuity. The contrast becomes even more striking when we examine the genetic evidence that these vanished populations left behind, not in their own lineages, which are lost forever, but in the genomes of other human species they encountered during their brief expansions. Ancient DNA extracted from Neanderthal and Denisovan fossils tells a story that no archaeological site could preserve. Evidence of contact, interbreeding, and genetic exchange between different kinds of humans in landscapes that no longer exist. This genetic archaeology reveals something profound about the nature of these early expansions. They weren't simple failures or evolutionary dead ends. They were complex encounters between different human lineages, meetings that left molecular traces even when the populations themselves vanished. The early modern humans who disappeared from European caves and Asian forests didn't simply die out in isolation. They met other humans, formed relationships, had children, and contributed genetic material that survives today in unexpected places. The most compelling evidence comes from Neanderthal genomes sequenced from sites across Europe and Western Asia. Buried within their DNA are segments that clearly derive from anatomically modern humans, but not from the populations that eventually spread across the globe. These genetic fragments are too old and too degraded to come from the later successful expansion around 60,000 years ago. Instead, they represent earlier encounters, meetings between Neanderthals and the vanished sapiens populations we've been tracking. The timing of these genetic exchanges corresponds precisely with the failed migrations we can trace archaeologically. Around 100,000 years ago, just as modern human fossils appear in sites like School and Kafse, Neanderthal genomes show the incorporation of sapiens DNA. The genetic signatures suggest not just occasional contact, but sustained interaction over thousands of years. These weren't brief encounters between hostile groups, but extended periods of coexistence and interbreeding. What makes this genetic evidence so poignant is its asymmetry. While Neanderthal genomes preserve traces of these ancient sapiens populations, modern human genomes show no reciprocal contribution from this early period. The sapiens lineages that interbred with Neanderthals left no direct descendants among living humans. Their genetic legacy survives only as fragments within other human species, a molecular ghost of populations that once walked the same paths we would later follow. This pattern repeats across different regions and time periods. Denisovan genomes from Siberian caves contain sapiens DNA that's even older than the Neanderthal contributions. High-altitude populations in Tibet and New Guinea carry Denisovan genetic variants that ultimately trace back to these ancient sapiens encounters. The successful expansion of modern humans around 60,000 years ago wasn't the first time our species left Africa. It was just the first time we stayed. The implications of this genetic evidence extend far beyond simple population history. It reveals a Pleistocene world that was far more interconnected than we typically imagine. Different human species weren't living in complete isolation, separated by vast empty territories. They were part of overlapping networks of contact and exchange that spanned continents. When early modern humans expanded into new regions, they entered landscapes that were already inhabited by other intelligent, tool-using humans. These encounters weren't always peaceful, but they weren't always violent either. The genetic evidence suggests periods of sustained coexistence, with interbreeding occurring regularly, enough to leave measurable traces in the archaeological record. Some researchers have suggested that certain stone tool traditions found in transitional sites might represent hybrid technologies, combining techniques from different human lineages. The demographic implications of these interactions were complex and probably varied by region and circumstance. In some cases, interbreeding might have strengthened small sapiens populations by providing additional genetic diversity and local environmental knowledge. Neanderthals had been adapting to European and Western Asian environments for hundreds of thousands of years. Their genetic contributions might have helped early sapiens populations survive in unfamiliar climates. But these genetic exchanges could also have contributed to the eventual disappearance of early sapiens populations. Interbreeding between closely related species often produces offspring with a reduced fertility or other reproductive disadvantages. Over several generations, this could lead to demographic decline even in otherwise successful populations. The same genetic mixing that initially appeared beneficial might have ultimately doomed the populations that participated in it. The geographic distribution of these ancient genetic exchanges provides clues about the roots and timing of early expansions. Sapiens DNA in European Neanderthal populations suggests contact zones in the Eastern Mediterranean and possibly the Balkans. Contributions to Denisovan genomes point to encounters in Central Asia or the Altai region. The absence of such ancient genetic signatures in other regions implies that some early expansions never made contact with other human species, dying out in isolation. This genetic mapping reveals something crucial about the nature of Pleistocene landscapes. The world wasn't empty wilderness waiting to be colonized by modern humans. It was a mosaic of territories occupied by different human lineages, each adapted to specific environmental conditions and resource bases. Early sapiens expansions weren't moving into vacant ecological niches, but into spaces already claimed by other intelligent competitors. The competitive dynamics of these multi-species landscapes probably played a significant role in determining which expansions succeeded and which failed. Neanderthals were better adapted to cold European environments, with robust builds and sophisticated hunting technologies suited to large game. Denisovans had successfully established themselves across much of Asia, from Siberian caves to tropical islands. Early sapiens populations entering these territories faced not just environmental challenges, but direct competition from other humans who knew the landscape intimately. Archaeological evidence supports this competitive interpretation. Many sites show alternating occupation by different human species, with Neanderthal layers overlying early sapiens deposits, or vice versa. These sequences suggest territories that changed hands multiple times, possibly as different populations gained temporary advantages through environmental changes or demographic fluctuations. The stone tool traditions associated with these mixed occupation sites often show interesting hybrid characteristics that might represent technological exchange between different human lineages. Tools that combine sapiens-style blade production with Neanderthal hafting techniques or Denisovan core preparation methods adapted for Sapiens-style projectile points. These technological innovations rarely lasted long in the archaeological record, disappearing when one or the other population gained dominance in the region. But some of these hybrid technologies might have been crucial stepping stones in the development of the more sophisticated toolkits that eventually made successful expansion possible. The populations that finally succeeded around 60,000 years ago carried with them technological innovations that had been tested and refined through thousands of years of interaction with other human species. They weren't starting from scratch, but building on accumulated knowledge that included contributions from multiple human lineages. The cultural implications of these ancient encounters extend beyond simple technology transfer. Interacting with other intelligent species would have forced early sapiens populations to develop more sophisticated social cognition. Recognizing the differences between your own group members and members of other human species, negotiating territorial boundaries, managing hybrid offspring, these challenges would have selected for enhanced cognitive abilities in areas like theory of mind, social planning, and cultural transmission. Some researchers have suggested that the cognitive demands of multi-species competition might have accelerated the development of symbolic thinking and complex language in early human populations. When you're competing with other intelligent species, the ability to coordinate complex group activities and transmit cultural knowledge rapidly becomes crucial for survival. The populations that developed these abilities most effectively would have had significant advantages in contested territories. The genetic evidence also reveals something unexpected about the durability of these ancient population interactions. DNA segments inherited from these early encounters weren't simply neutral passengers in Neanderthal and Denisovan genomes. Some of them appear to have been actively selected for, suggesting that they provided adaptive advantages in specific environments. Genes affecting immune system function, skin pigmentation, and cold adaptation show signatures of positive selection in recipient populations. This pattern suggests that the genetic contributions from early sapiens populations weren't just random byproducts of interbreeding. They represented adaptive solutions to environmental challenges that had been developed by populations with different evolutionary histories. When Neanderthals incorporated sapiens DNA affecting immune function, they gained access to pathogen resistance that had evolved in African environments. When Denisovans acquired sapiens genetic variants affecting high-altitude adaptation, they could exploit ecological niches that had previously been inaccessible. The reciprocal flow of adaptive genetic variants between different human lineages created a kind of evolutionary braiding that connected the fates of these species in unexpected ways. Even as sapiens populations disappeared from the archaeological record, their genetic innovations lived on in the genomes of their competitors and neighbours. Some of the adaptations that made later sapiens expansion successful might have originally evolved through this process of interspecies genetic exchange. This genetic archaeology transforms our understanding of what it means for early human populations to have failed. While these populations left no direct descendants, their genetic contributions continue to influence human evolution today. Every person of non-African ancestry carries Neanderthal DNA that ultimately traces back to these ancient sapiens encounters. Populations in New Guinea and Tibet carry Denisovan genetic variants that reflect even more ancient exchanges. The vanished migrations weren't evolutionary dead ends. They were genetic tributaries that fed into the river of human evolution. The psychological impact of these multi-species encounters on early human populations is harder to reconstruct, but probably equally significant. Imagine being part of a small sapiens group that encounters Neanderthals for the first time. These are clearly human. They make tools, control fire, bury their dead, but they're also, obviously, different. taller, more robust, with distinctive facial features and possibly different vocal capabilities. How do you process such an encounter? How do you decide whether to fight, flee, or attempt communication? The genetic evidence suggests that our ancestors often chose communication and cooperation, at least initially. But the demographic mathematics of small populations meant that such encounters could have profound consequences regardless of their immediate outcomes. Even friendly interactions that led to interbreeding could destabilize population dynamics in ways that eventually led to local extinction. The children of mixed unions might have found themselves caught between different cultural traditions, never fully accepted by either parent population. If they inherited intermediate physical characteristics, they might have been recognizable as outsiders wherever they went. Over time, this could lead to the emergence of hybrid populations that were genetically and culturally distinct from both parent groups, but too small to be viable on their own. Archaeological evidence for such hybrid populations is necessarily ambiguous, but some sites show artifact assemblages that don't fit clearly into any known cultural tradition. Tools that combine elements from different technological systems, burial practices that blend different ritual traditions, settlement patterns that don't match known models for any specific human lineage. These anomalous sites might represent the archaeological signatures of populations that were caught between different human worlds. The eventual disappearance of these hybrid populations adds another layer of tragedy to the story of early human expansion. They represented unique experiments in human cultural evolution, combining innovations from different lineages in ways that might have led to remarkable adaptations, but their small size and uncertain social status made them vulnerable to demographic accidents and cultural assimilation. Most vanished without leaving clear traces in either the archaeological or genetic record. Understanding these complex population dynamics helps explain why successful human expansion took so long to achieve. It wasn't enough to develop better tools or larger founding populations. Expanding humans also had to learn to navigate a world occupied by other intelligent species, each with their own territorial claims and adaptive strategies. This required not just technological innovation, but sophisticated social and diplomatic skills that took millennia to develop. The populations that eventually succeeded in permanent expansion carried with them the accumulated wisdom of all these earlier encounters. They knew how to recognize and interact with other human species. They had genetic variants that had been tested through thousands of years of multi-species competition. They possessed cultural practices that had been refined through contact with alternative approaches to human social organization. Most importantly, they had learned from the failures of their predecessors. Each vanished population had provided data points about what worked and what didn't in contested territories. Each genetic exchange had tested the viability of different adaptive combinations. Each cultural hybrid had experimented with new approaches to human social organization. The successful expansion around 60,000 years ago built on this foundation of accumulated experience. But even this successful expansion was shaped by the legacy of these ancient encounters. The modern humans who spread across the globe weren't genetically pure descendants of African populations. They carried with them Neanderthal and Denisovan DNA acquired through earlier phases of expansion and retreat. They possessed cultural innovations that had been developed through millennia of interspecies contact. They were, in a very real sense, the products of a multi-species evolutionary process that had been unfolding for hundreds of thousands of years. This perspective transforms our understanding of what makes humans unique. We're not the inevitable victors in a competition between different human species. We're the surviving representatives of a complex web of evolutionary relationships that included multiple intelligent lineages. Our success wasn't due to inherent superiority, but to our ability to incorporate innovations from other human species while maintaining our own cultural and genetic identity. The vanished migrations we've been exploring weren't just failed attempts at expansion. They were essential phases in a long process of interspecies interaction and exchange that ultimately produced the cultural and genetic foundations for successful human expansion. Their disappearance wasn't a simple failure of adaptation, but part of a complex evolutionary experiment that tested different approaches to human social organization under Pleistocene conditions. The real turning point wasn't a single moment of breakthrough, but a slow accumulation of changes that made the difference between vanishing and persisting. Around 70,000 years ago, something shifted in the way human populations organized themselves, and this time, when they walked out of Africa, they didn't disappear. What changed wasn't their anatomy or their basic intelligence. The humans who finally succeeded weren't fundamentally different from those who had failed before them, but they carried something new, a set of cultural innovations that had been tested and refined through millennia of demographic experimentation within Africa itself. While their predecessors were vanishing from caves in Greece and lake shores in Arabia, populations back home were developing the social technologies that would eventually make permanent expansion possible. The evidence for this cultural revolution appears gradually in African archaeological sites from this period. Not dramatic cave paintings or elaborate burials, but subtler innovations that reveal populations learning to think beyond immediate survival. Compound adhesives allowed for more sophisticated tool construction, heat treatment of stone importantly, symbolic artifacts become more common and more standard improved the reliability of weapon production. Most dies across vast distances. These symbolic markers weren't just decorative, they represented something unprecedented in time. Populations separated by thousands of kilometers word, the ability to maintain cultural identity across space producing similar shell beads, using similar ochre preparation techniques, following similar burial practices. This suggests communication networks that could preserve and transmit cultural innovations across the entire continent. The demographic implications were profound. Instead of fragmenting into isolated bands when facing environmental stress, African populations were learning to maintain connections that could provide mutual support during difficult periods. When local conditions deteriorated, groups could relocate without losing cultural continuity. When populations shrank below viable levels, they could merge with neighbours without abandoning their essential knowledge systems. This networking ability transformed the mathematics of population survival. Small groups were no longer demographic islands, vulnerable to every environmental fluctuation. They became nodes in larger systems that could absorb losses and redistribute resources as needed. The cultural practices that emerged from this connectivity weren't just more sophisticated than earlier traditions, they were more resilient. Archaeological sites from this period show evidence of these new survival strategies in action. Tool assemblages become more standardized, suggesting shared learning systems that could preserve technical knowledge across generations. Raw materials appear far from their sources, indicating trade networks that moved resources where they were needed most. Settlement patterns show greater flexibility, with sites being abandoned and reoccupied in response to environmental changes rather than being occupied until demographic collapse. The contrast with contemporary sites outside Africa is striking. While African populations were developing increasingly sophisticated social technologies, the scattered sapiens groups in Europe and Asia show no evidence of such innovations. Their tool traditions remain purely functional. Their settlement patterns suggest small, isolated groups focused entirely on immediate survival. There's no indication of the cultural investments that might have helped them weather demographic storms. This difference reveals something crucial about what successful expansion actually required. It wasn't enough to reach new territories or develop better hunting techniques. Permanent settlement demanded social organizations that could maintain viable populations under the challenging conditions that had doomed earlier attempts. The African populations of this period were developing exactly these capabilities. The process wasn't uniform or immediate. Different regions of Africa contributed different innovations to this emerging cultural toolkit. Coastal populations developed maritime technologies that would later prove crucial for island colonization. Highland groups perfected cold weather adaptations that would be essential for expansion into northern latitudes. Desert edge communities learned resource management techniques that could sustain populations through extended dry periods. But the most important innovation may have been the development of cultural practices that could integrate these diverse adaptations into coherent survival systems. Instead of each population developing solutions in isolation, African communities were learning to share innovations across ecological boundaries. A coastal fishing technique could be adapted for use around inland lakes. A highland hunting strategy could be modified for use in savanna environments. This cultural integration created something unprecedented in human evolution, a continental-scale knowledge base that could be accessed by any population connected to the network. When groups finally began expanding out of Africa around 60,000 years ago, they weren't carrying just their own local adaptations. They were carrying the accumulated wisdom of an entire continent. The genetic evidence supports this interpretation. Unlike earlier expansions that show signs of severe bottlenecks and genetic isolation, the successful expansion maintained surprisingly high levels of diversity. This suggests founding populations that were larger and better connected to their source communities. They weren't desperate refugees fleeing environmental collapse, but confident colonists backed by sophisticated support networks. The archaeological signature of this confidence appears in the cultural continuity between African and non-African sites from this period. Tool traditions that appear in East Africa quickly show up in Arabian sites, then in Indian assemblages, then in Southeast Asian contexts. This isn't just technological diffusion, it's evidence of populations that maintained cultural connections across vast distances and diverse environments. More remarkably, these expanding populations didn't simply abandon their African cultural practices when facing new challenges. Instead, they adapted these practices to new circumstances while preserving their essential characteristics. This represents a sophisticated approach to cultural change that balanced innovation with continuity, allowing populations to remain flexible without losing their cultural identity. The social mechanisms that made this possible are visible only indirectly in the archaeological record, but their effects are unmistakable. Successful expansion sites show evidence of larger group sizes, more systematic resource exploitation, and greater cultural standardization than earlier attempts. Tool production becomes more efficient and predictable. Settlement patterns show better integration with local environments. Most tellingly, occupation continues without interruption, even during periods of environmental stress that had caused earlier populations to disappear. This resilience wasn't just technological, it was fundamentally social, based on organizational innovations that could maintain group cohesion and cultural knowledge under conditions that had previously led to demographic collapse. The expanding populations had learned to create demographic buffers through larger community sizes and intergroup networks. They had developed systems for preserving essential knowledge that could survive the loss of key individuals. Most importantly, they had cultural practices that supported psychological as well as physical survival during extended periods of hardship. The evidence for these psychological adaptations appears in the persistence of non-functional cultural practices in new territories. Successful expansion populations continue to produce symbolic artifacts, maintain ritual practices, and invest resources in activities that serve no obvious survival purpose. This suggests communities that were consciously maintaining cultural identities rather than simply focusing on immediate needs. These cultural investments required resources that earlier populations might have devoted entirely to subsistence activities, but they provided psychological benefits that proved crucial for long-term survival. Populations that maintained rich cultural lives were more resilient to the stresses of life in unfamiliar territories. They were more likely to preserve the social cohesion necessary for collective decision-making and mutual support during crises. The contrast becomes even more apparent when examining how these successful populations handled contact with other human species. Unlike their predecessors, who seem to have been overwhelmed by encounters with Neanderthals and Denisovans, the later expansion populations managed these interactions more effectively. They interbred selectively, acquiring useful genetic variants while maintaining their cultural distinctiveness. They adopted useful technologies while preserving their own innovations. This sophisticated approach to interspecies contact reflects the cultural maturity that African populations had developed during the long period of internal networking and innovation. They had learned to incorporate external influences without losing their essential identity. They could adapt to new environments without abandoning the social practices that made adaptation possible. The demographic success of these populations created a positive feedback loop that accelerated their expansion. Larger, more stable communities could support greater specialization and innovation. Better organized groups could exploit resources more efficiently and respond more effectively to environmental challenges. Most importantly, successful communities could serve as staging areas for further expansion, providing demographic and cultural support for new colonization efforts. This cascading effect explains why the successful expansion around 60,000 years ago proceeded so much more rapidly than earlier attempts. Instead of isolated pioneer groups struggling to establish themselves in hostile territories, expanding populations could draw on support networks that stretched back to Africa. They weren't just colonizing new lands, they were extending existing social systems into new environments. The speed of this expansion was unprecedented in human evolution. Within roughly 20,000 years, modern human populations had established themselves across Eurasia, reached Australia, and begun moving into the Americas. This wasn't gradual diffusion, but rapid, coordinated movement that suggests populations with sophisticated planning capabilities and extensive logistical support. Archaeological sites from this period show evidence of this coordination in their consistent cultural signatures. Similar tool technologies appear simultaneously across vast distances. Symbolic artifacts follow standardized patterns that connect sites from Africa to Australia. Even burial practices show remarkable consistency, suggesting populations that maintained cultural communication across continents. But perhaps the most impressive aspect of this expansion was its sustainability. Unlike earlier attempts that flickered briefly before disappearing, these populations established themselves permanently in every environment they encountered. They developed cold weather adaptations that allowed survival in Ice Age Europe. They created maritime technologies that enabled island colonization across the Pacific. They evolved high-altitude physiologies that made life possible in mountain ranges. Each of these adaptations built on the cultural foundation that had been developed during the long period of African innovation. The social technologies that enabled survival in small populations, the networking practices that preserved cultural knowledge, the demographic strategies that maintained group cohesion, all of these innovations proved transferable to new environments and new challenges. The genetic legacy of this successful expansion is visible today in the DNA of every non-African population. But more importantly, the cultural legacy continues to shape human societies around the world. The networking practices that enabled initial expansion evolved into the trade systems that connected ancient civilizations. The demographic innovations that prevented population collapse became the social institutions that support modern communities. The cultural practices that preserved knowledge through environmental crises became the educational systems that transmit information across generations. Understanding this continuity transforms how we think about human achievement. The technologies that enabled space exploration, the social organizations that coordinate global economies, the cultural practices that preserve knowledge through digital networks, all of these innovations trace their ancestry back to the cultural revolution that made successful expansion out of Africa possible. The vanished migrations we explored weren't just evolutionary failures. They were essential experiments that provided the data points necessary for developing viable expansion strategies. Each disappeared population contributed to a species-wide learning process that eventually produced the cultural innovations necessary for permanent settlement outside Africa. Their failures weren't signs of inadequacy, but evidence of the extraordinary difficulty of the challenge they faced. The humans who finally succeeded weren't superior to those who had failed before them. They were the beneficiaries of accumulated wisdom that had been built through millennia of demographic experimentation. Their success was possible only because of the failures that had preceded them, failures that had slowly pushed human societies toward greater complexity and resilience. This perspective reveals something profound about the nature of human progress. Innovation doesn't emerge from individual genius or sudden breakthroughs. It develops through long processes of trial and error that build on the accumulated experience of countless earlier attempts. The successful expansion of modern humans represents the culmination of one of the longest research and development projects in evolutionary history. Every stable human population today exists because earlier populations learned, through trial and error, how to survive the demographic challenges that had doomed their predecessors. Every cultural innovation that makes modern life possible traces its origins back to survival strategies that were first tested by small groups of humans facing extinction in unfamiliar territories. The archaeological record of human expansion is ultimately a record of learning how to maintain viable populations under harsh conditions, learning how to preserve essential knowledge through environmental crises, learning how to adapt to new environments without losing cultural identity. The populations that vanished along the way weren't evolutionary dead ends. They were teachers, providing lessons that eventually enabled their species to spread across the globe. But this learning process didn't end with successful expansion. It continues today as human populations face new challenges that require innovative solutions. Climate change, resource depletion, demographic transitions. These modern challenges echo the problems that faced our ancestors as they struggled to establish themselves in unfamiliar territories. The solutions that enable contemporary human societies to thrive build on the same cultural foundations that made initial expansion possible. The story of the migrations that failed is ultimately a story about resilience and the price of learning to survive in an unpredictable world. It reminds us that human success isn't inevitable or predetermined, but depends on cultural innovations that must be constantly maintained and adapted to new circumstances. The wisdom that enabled our ancestors to spread across the globe continues to be essential for navigating the challenges of an interconnected world. Understanding these ancient failures and eventual success provides perspective on contemporary human challenges. The same demographic vulnerabilities that doomed early expansion attempts continue to threaten small populations today. The same environmental pressures that closed migration corridors continue to shape human movement patterns. The same cultural innovations that enabled survival in unfamiliar territories continue to be necessary for adapting to rapidly changing conditions. The archaeological record suggests that successful human adaptation has always required balancing innovation with continuity, maintaining cultural identity while adapting to new circumstances. The populations that thrived were those that could preserve essential knowledge while remaining flexible enough to respond to changing conditions. This balance remains crucial for contemporary human societies facing unprecedented rates of environmental and technological change. The legacy of those vanished migrations lives on in every human community that has learned to survive in challenging environments. Their experiments in demographic organization, cultural transmission, and environmental adaptation continue to inform human societies around the world. Their failures provided the foundation for successes that continue to shape human civilization today. The story continues to unfold as researchers develop new techniques for detecting ancient human presence and understanding the cultural innovations that made expansion possible. Each new discovery adds another piece to the puzzle of human resilience, revealing processes that remain relevant for contemporary challenges. The archaeological record of human expansion is not just ancient history, it's a guide for navigating an uncertain future. In our final exploration of this topic, we'll examine how the cultural innovations that enabled successful expansion continue to influence human societies today, and what lessons these ancient experiments in survival might offer for addressing contemporary challenges. The story of human expansion is far from over. It's a continuing process of adaptation and innovation that connects our ancient past to our uncertain future. The patterns we've traced through 150,000 years of failed migrations reveal something unsettling about human survival. Each wave of pioneers who ventured beyond Africa carried the same basic toolkit, the same anatomical capabilities, the same fundamental intelligence as those who would eventually succeed. Yet they vanished, leaving only scattered bones and stone tools as evidence they ever existed. Understanding why these early attempts failed while later ones succeeded requires us to look beyond individual adaptations and examine the deeper currents of demographic and cultural change that shaped our species during this crucial period. The mathematics of extinction in small populations follows predictable patterns that archaeologists can trace through the sediment layers of abandoned sites. When a founding group establishes itself in new territory, initial success often masks underlying vulnerabilities that only become apparent over generations. A community of 40 individuals might thrive for decades, successfully hunting local game, gathering seasonal resources, and maintaining their cultural traditions. But demographic stability in such small groups is largely illusory. Random variation in birth rates and sex ratios can quickly destabilize even successful communities. A generation that produces mostly male children creates a bottleneck that reverberates through subsequent generations. The loss of key individuals through accident, disease, or predation removes irreplaceable knowledge from the community's collective memory. Over time, these accumulated stresses push populations toward what demographers call an extinction vortex, where declining numbers make further decline increasingly likely. Archaeological evidence for these demographic collapses appears in the stratigraphic record as cultural discontinuities. Tool traditions that had persisted for centuries suddenly disappear from excavation layers. Settlement patterns shift abruptly, with no gradual transition between old and new practices. Most tellingly, many sites show evidence of declining population density over time, with later occupation layers containing fewer artifacts and less diverse cultural materials than earlier periods. The Levantine caves that preserve evidence of early human occupation provide particularly clear examples of this pattern. At sites like Skul and Kafsa, rich cultural layers containing sophisticated burial practices and symbolic artifacts are followed by periods of complete abandonment. When human occupation resumes at these locations, it often involves completely different populations with no apparent connection to earlier inhabitants. This discontinuity suggests that early human populations outside Africa weren't simply evolving in place, gradually developing more sophisticated survival strategies. Instead, they were being replaced by entirely new groups, often after significant gaps in the archaeological record. The implication is that local populations were dying out completely, leaving empty territories that could later be recolonized by fresh waves of migrants. The environmental triggers for these demographic collapses often appear subtle in the geological record. A shift in rainfall patterns might reduce the reliability of seasonal water sources. Changes in vegetation could alter the distribution of game animals. Even minor climate fluctuations could disrupt the delicate balance that allowed small populations to survive in marginal environments. But environmental stress alone doesn't explain why some populations collapsed while others persisted. Contemporary climate changes affected all human groups in a given region, yet the archaeological record shows differential survival rates that suggest some communities were more resilient than others. The key difference appears to have been social organization and the cultural practices that supported demographic stability under stress. The most successful early populations were those that developed mechanisms for maintaining larger group sizes and preserving cultural knowledge across generations. Archaeological sites associated with longer-term survival show evidence of more systematic resource exploitation, suggesting communities that could support higher population densities. Tool assemblages from these sites are more standardized and sophisticated, indicating cultural traditions that could preserve technical knowledge effectively. Perhaps most importantly, successful sites show evidence of connections with other human communities. Raw materials appear from distant sources, suggesting trade networks or population movements that could provide demographic reinforcement during difficult periods. Similar artifact styles appear at multiple sites, indicating shared cultural traditions that connected otherwise isolated populations. These networking practices created demographic buffers that could absorb losses and redistribute resources as needed. When local conditions deteriorated, groups could relocate without losing cultural continuity. When populations shrank below viable levels, they could merge with neighbours without abandoning essential knowledge systems. Communities that developed these social technologies were far more likely to survive environmental crises that doomed more isolated populations. The contrast between successful and failed populations becomes even more apparent when examining their responses to contact with other human species. Early sapiens groups that encountered Neanderthals or Denisovans faced complex challenges that went beyond simple territorial competition. These meetings required sophisticated social cognition and diplomatic skills that many small isolated populations may not have possessed. Genetic evidence suggests that some early modern human populations interbred extensively with other human species, acquiring useful genetic variants while potentially destabilizing their own demographic structure. The children of mixed unions might have faced social acceptance problems that reduced their reproductive success. Over time, extensive interbreeding could have led to the emergence of hybrid populations that were too small and socially marginal to survive independently. Archaeological sites that show evidence of contact between different human species often preserve artifact assemblages that don't fit clearly into known cultural traditions. Tools that combine technological elements from different human lineages, burial practices that blend different ritual traditions, settlement patterns that don't match established models for any specific species. These anomalous sites might represent the archaeological signatures of hybrid populations that were caught between different human worlds. The eventual disappearance of these culturally intermediate populations adds another layer of complexity to the story of early human expansion. They represented unique experiments in human social organization, combining innovations from different lineages in ways that might have produced remarkable adaptations. But their ambiguous social status and small population sizes made them vulnerable to demographic accidents and cultural assimilation. Understanding these complex interaction dynamics helps explain why successful human expansion required more than just technological innovation or environmental opportunity. Expanding populations also needed sophisticated social skills for navigating a world occupied by other intelligent species. They had to learn when to compete, when to cooperate, and when to avoid contact entirely. These diplomatic capabilities took time to develop and were probably refined through many unsuccessful encounters. The populations that eventually succeeded in permanent expansion carried with them the accumulated wisdom of all these earlier interactions. They knew how to recognize and respond to other human species. They possessed genetic variants that had been tested through thousands of years of multi-species competition. They had cultural practices that had been refined through contact with alternative approaches to human organization. But perhaps most importantly, they had learned to maintain their cultural identity while adapting to new circumstances. Unlike earlier populations that seem to have been either overwhelmed by contact with other species or completely isolated from them, successful expansion groups managed these relationships more effectively. They could acquire useful innovations from other populations while preserving their own essential characteristics. This cultural resilience appears in the archaeological record through the persistence of African technological traditions in non-African contexts. Tool-making techniques that first appear in East African sites quickly show up in Arabian assemblages, then in Indian contexts, then throughout Southeast Asia. This isn't just technological diffusion, it's evidence of populations that maintained cultural connections across vast distances while adapting to diverse local conditions. The speed and consistency of this technological spread suggests something unprecedented in human evolution: the development of cultural transmission systems that could preserve and disseminate innovations across continental distances. Earlier human populations had developed sophisticated local adaptations, but they lacked the social technologies necessary for sharing these innovations broadly. The successful expansion populations had somehow solved this fundamental problem of cultural scaling. Archaeological evidence suggests that the solution involved developing standardized cultural practices that could be maintained across diverse environments, instead of each local population developing unique adaptations to their specific circumstances. Expanding groups preserved core cultural elements while allowing peripheral innovations to vary with local conditions. This created a kind of cultural modularity that combined stability with flexibility. The demographic implications were profound. Populations that maintained cultural connections could draw on innovations developed elsewhere when facing local challenges. A hunting technique developed in one environment could be adapted for use in different contexts. A tool technology that proved successful in one region could be quickly transmitted to populations facing similar challenges elsewhere. This cultural networking created survival advantages that went far beyond what any individual community could achieve in isolation. The genetic evidence supports this interpretation of successful expansion as a networked rather than isolated process. Unlike earlier expansions that show severe bottleneck effects and high levels of genetic drift, the successful expansion maintained surprising levels of diversity across vast distances. This suggests populations that remained connected to their source communities and continued to exchange genetic material even after establishing themselves in distant territories. Modern studies of successful colonization events show that maintaining connections with source populations is crucial for long-term survival in new environments. Isolated founder populations face genetic and cultural deterioration that often leads to eventual extinction. But populations that preserve umbilical connections to larger networks can draw on external resources and knowledge that help them weather local crises. The archaeological signature of these maintained connections appears in the cultural continuity between African and non-African sites throughout the successful expansion period. Not only do similar technologies appear across vast distances, but they appear simultaneously. suggesting rapid communication and coordination between populations separated by thousands of kilometers. This level of cultural integration was unprecedented in human evolution and probably represents one of the key innovations that made permanent expansion possible. The social mechanisms that enabled such extensive networking are visible only indirectly in the archaeological record, but their effects are unmistakable. Successful expansion populations show evidence of larger group sizes, more systematic resource exploitation, and greater cultural standardization than earlier attempts. They also show remarkable consistency in symbolic practices, suggesting shared belief systems that could maintain group identity across diverse environments. These symbolic innovations weren't just decorative additions to practical survival strategies. They represented fundamental changes in how human societies organized themselves and maintained cohesion under stress. Shared symbolic systems allowed large groups to coordinate activities without requiring face-to-face interaction. They enabled the preservation of cultural knowledge in forms that could survive the loss of key individuals. Most importantly, they created psychological bonds that could maintain group loyalty even during extended periods of hardship. The contrast with earlier failed populations is striking. Archaeological sites outside Africa from earlier periods show little evidence of symbolic elaboration or social complexity. Tool assemblages remain purely functional. Settlement patterns suggest small groups focused entirely on immediate survival. There's no indication of the cultural investments that might have helped these populations develop the networking capabilities necessary for long-term success. This difference reveals something crucial about the nature of successful human expansion. It wasn't enough to reach new territories or develop better survival techniques. Permanent settlement required social innovations that could maintain viable communities under conditions that had repeatedly caused earlier populations to disappear. The successful expansion populations had somehow developed these social technologies during the long period of demographic experimentation within Africa. The process wasn't uniform or immediate. Different regions of Africa contributed different elements to this emerging social toolkit. Coastal populations developed maritime technologies and long-distance trade networks. Highland groups perfected resource management techniques and cold weather adaptations. Desert edge communities learned strategies for surviving extended dry periods and maintaining cultural continuity during environmental stress. But the most important innovation was the development of cultural practices that could integrate these diverse adaptations into coherent survival systems. Instead of each population developing solutions in isolation, African communities learned to share innovations across ecological boundaries. This created a continental-scale knowledge base that could be accessed by any population connected to the network. When groups finally began expanding successfully out of Africa around 60,000 years ago, they weren't carrying just their own local adaptations. They were carrying the accumulated wisdom of an entire continent, refined through millennia of demographic experimentation and cultural innovation. This gave them unprecedented advantages over earlier expansion attempts, which had relied on the limited knowledge bases of small isolated populations. The archaeological evidence shows this accumulated wisdom in action. Successful expansion sites preserve evidence of sophisticated resource management strategies that had been developed and tested in African contexts. Tool technologies appear that represent the culmination of thousands of years of incremental improvement. Most tellingly, cultural practices emerge that seem specifically designed to prevent the demographic collapses that had doomed earlier populations. The demographic innovations are particularly impressive. Successful expansion populations show evidence of maintaining larger community sizes and more complex social organizations than their predecessors. They developed systems for preserving essential knowledge that could survive the loss of key individuals. They created cultural practices that supported psychological as well as physical survival during extended hardship periods. These social technologies weren't abstract theoretical constructs. They had concrete implications for how expanding populations organized themselves and responded to challenges. Archaeological sites show evidence of more systematic resource exploitation, better integration with local environments, and greater cultural continuity over time. Most importantly, occupation continues without interruption, even during environmental stress periods that had caused earlier populations to disappear. The resilience of successful expansion populations created positive feedback loops that accelerated their spread across the globe. Stable communities could support greater specialization and innovation. Well-organized groups could exploit resources more efficiently and respond more effectively to challenges. Most importantly, successful communities could serve as staging areas for further expansion, providing demographic and logistical support for new colonization efforts. This cascading effect explains why the successful expansion proceeded so much more rapidly than earlier attempts. Instead of isolated pioneer groups struggling to establish themselves in hostile territories, expanding populations could draw on support networks that stretched back to Africa. They weren't just colonizing new lands, they were extending existing social systems into new environments. The speed of this expansion was unprecedented in human evolution. Within roughly 20,000 years, modern human populations had established themselves across Eurasia, reached Australia, and begun moving into the Americas. This wasn't gradual diffusion but rapid, coordinated movement that suggests populations with sophisticated planning capabilities and extensive logistical support. The cultural legacy of this successful expansion continues to shape human societies today. The networking practices that enabled initial expansion evolved into the trade systems that connected ancient civilizations. The demographic innovations that prevented population collapse became the social institutions that support modern communities. The symbolic practices that preserved cultural knowledge became the educational systems that transmit information across generations. Understanding this continuity between ancient and modern survival strategies provides perspective on contemporary human challenges. The same demographic vulnerabilities that doomed early expansion attempts continue to threaten small populations today. The same environmental pressures that closed ancient migration corridors continue to shape human movement patterns. The same social innovations that enabled survival in unfamiliar territories remain necessary for adapting to rapidly changing conditions. The archaeological record suggests that successful human adaptation has always required balancing innovation with continuity, maintaining cultural identity while adapting to new circumstances. The populations that thrived were those that could preserve essential knowledge while remaining flexible enough to respond to changing conditions. This balance remains crucial for contemporary societies facing unprecedented rates of environmental and technological change. The story of human expansion ultimately reveals that survival isn't just about individual capability or technological sophistication. It's about developing social organizations that can maintain viable communities under challenging conditions. The populations that vanished from the archaeological record weren't failures. They were experiments that provided essential data for developing more effective survival strategies. Each disappeared community contributed to a species-wide learning process that eventually produced the cultural innovations necessary for permanent settlement outside Africa. Their failures weren't signs of inadequacy, but evidence of the extraordinary difficulty of the challenges they faced. The humans who finally succeeded weren't superior to those who had failed before them. They were the beneficiaries of accumulated wisdom built through millennia of demographic experimentation. This perspective transforms our understanding of human achievement and progress. Innovation doesn't emerge from individual genius or sudden breakthroughs, but develops through long processes of trial and error that build on accumulated experience. The successful expansion of modern humans represents the culmination of one of the longest research and development projects in evolutionary history. The legacy of those vanished migrations lives on in every human community that has learned to survive in challenging environments. Their experiments in demographic organization, cultural transmission, and environmental adaptation continue to inform societies around the world. Their failures provided the foundation for successes that continue to shape human civilization. The story continues to unfold as new techniques reveal ancient human presence and the cultural innovations that made expansion possible. Each discovery adds another piece to the puzzle of human resilience, revealing processes that remain relevant for contemporary challenges. The archaeological record of human expansion isn't just ancient history, it's a guide for navigating an uncertain future where the same fundamental challenges of demographic stability and cultural adaptation continue to shape human societies. The weight of these discoveries forces us to confront an uncomfortable truth about human nature itself. We are not the inevitable victors of some grand evolutionary competition. We are the survivors of a process so contingent, so dependent on chance and circumstance, that it's almost miraculous we exist at all. Every person alive today carries within their cells the genetic echoes of populations that tried and failed to establish themselves beyond Africa's borders. We are walking museums of vanished experiments in human survival. Consider what this means for how across the globe wasn't born from in her we understand ourselves. The confidence with which modern humans sprint superiority or divine destiny. It emerged from a grinding process of trial and error that consumed entire populations in its slow march toward viable solutions. The cultural innovations that enabled our ancestors to survive in unfamiliar territories were purchased with the disappearance of countless communities who tested earlier versions of these same strategies. The archaeological record preserves only fragments of these lost experiments. A hearth that went cold and was never relit. Tool traditions that simply stop appearing in the sediment layers. Burial practices that end abruptly with no explanation. Behind each of these silences lies a story of people who woke up one morning not knowing it would be among the last times their community would see the sun rise together. The demographic mathematics that doomed these early populations operate according to principles that remain unchanged today. Small isolated communities face the same vulnerabilities now that they faced 100,000 years ago. Random variations in birth rates can destabilize entire societies. The loss of key individuals can trigger cascading failures that doom otherwise viable populations. Environmental stresses that larger communities might weather easily can push small groups past the point of recovery. Modern examples of these demographic traps appear regularly in the contemporary world. Island populations that thrived for centuries can collapse within a few generations when tourism disrupts traditional economies. Indigenous communities that survived colonial pressures for centuries can disappear when younger generations migrate to cities. Even wealthy suburban communities can experience demographic collapse when economic changes make their lifestyles unsustainable. The parallels with ancient failed migrations are striking. In each case, populations that appear stable and successful from the outside are actually balanced on the edge of demographic sustainability. Small changes in their environment or social structure can trigger rapid decline that becomes irreversible once critical thresholds are crossed. The communities that survive are those that maintain the social technologies necessary for demographic stability under changing conditions. But understanding these patterns also reveals something hopeful about human adaptability. The same species that produced so many failed migrations eventually developed the cultural innovations necessary for permanent expansion. The social technologies that enabled survival in unfamiliar territories weren't gifts from the gods, or products of genetic mutation. They were learned behaviors that emerged through collective experience and were refined through generations of practice. This suggests that contemporary communities facing demographic challenges aren't doomed by forces beyond their control. Like their ancient predecessors, they can develop cultural innovations that improve their chances of long-term survival. The key is understanding which social practices support demographic stability and which ones undermine it. The archaeological record provides a vast database of experiments in human survival that can inform modern efforts to build resilient communities. The most successful ancient populations were those that developed mechanisms for maintaining connections with other communities. Trade networks, marriage exchanges, and cultural sharing all served to create demographic buffers that could absorb losses and provide support during difficult periods. Modern communities that isolate themselves from broader social networks face the same vulnerabilities that doomed many early expansion attempts. Conversely, communities that maintain diverse connections with other populations tend to be more resilient to demographic shocks. They can draw on external resources during local crises. They can absorb new members when their own birth rates decline. They can learn from the experiences of other communities facing similar challenges. These networking practices create survival advantages that go far beyond what any isolated community can achieve on its own. The cultural dimension of demographic survival is equally important. Communities that invest in preserving and transmitting knowledge across generations are more likely to survive environmental changes that require adaptive responses. Those that maintain rich cultural traditions tend to have stronger social cohesion and higher birth rates. Most importantly, populations that develop cultural practices specifically designed to prevent demographic collapse are far more likely to persist through difficult periods. Archaeological evidence suggests that successful ancient populations devoted significant resources to these cultural investments even during times of environmental stress. They continued producing symbolic artifacts, maintaining ritual practices, and investing in activities that served no immediate survival purpose. These cultural practices provided psychological benefits that proved crucial for long-term demographic stability. They created social bonds that could maintain group cohesion during extended hardships. The contrast with failed populations is instructive. Archaeological sites associated with demographic collapse often show evidence of cultural simplification in their final phases. Tool assemblages become cruder and less diverse. Symbolic artifacts disappear from the record. Settlement patterns suggest communities focused entirely on immediate survival, with no investment in long-term cultural sustainability. These populations seem to have abandoned the very practices that might have helped them weather their crises. This pattern suggests that communities facing demographic stress often make counterproductive decisions that accelerate their decline. The natural response to resource scarcity is to eliminate non-essential activities and focus on immediate needs. But many cultural practices that seem non-essential actually serve crucial functions for maintaining social cohesion and demographic stability. Communities that abandon these practices may improve their short-term survival chances while undermining their long-term viability. The implications extend beyond simple resource management to fundamental questions about what makes human communities sustainable. Populations that define themselves purely in economic terms, focusing exclusively on material prosperity and resource accumulation, may be more vulnerable to demographic collapse than those that maintain broader cultural identities. The archaeological record suggests that the most resilient populations were those that balanced practical survival needs with investments in social and cultural sustainability. This perspective challenges many contemporary assumptions about what makes societies successful. Communities that appear thriving by conventional measures may actually be quite vulnerable if they lack the social technologies necessary for demographic stability. Conversely, populations that seem backward or inefficient by modern standards may possess cultural innovations that make them more resilient to environmental and social changes. The failed migrations we've been exploring offer particularly valuable insights because they represent controlled experiments in human survival under challenging conditions. Each vanished population tested specific combinations of technological, social, and cultural adaptations under well-documented environmental conditions. Their failures and successes provide data points about which survival strategies work under various circumstances. The most consistent pattern in these ancient experiments is the importance of maintaining viable population sizes through social rather than purely biological mechanisms. Communities that developed cultural practices encouraging higher birth rates were more likely to survive demographic accidents. Those that created social institutions supporting child rearing and elder care could maintain stable age structures even during difficult periods. Most importantly, populations that established mechanisms for incorporating new members from outside their original gene pool could avoid the genetic deterioration that often accompanies small population sizes. These social technologies weren't abstract theoretical constructs. They had concrete implications for how communities organized daily life, made collective decisions, and responded to crises. Archaeological sites preserve evidence of these practices in the form of settlement patterns, artifact distributions, and burial practices. Communities with more sophisticated social organizations tend to leave more complex archaeological signatures that reflect their greater cultural elaboration. The evolution of these social technologies can be traced through the archaeological record as increasingly sophisticated solutions to fundamental problems of human survival. Early populations relied primarily on kinship ties and face-to-face relationships to maintain social cohesion. Later groups developed symbolic systems that could maintain group identity across larger populations and greater distances. The most successful populations created cultural practices that could preserve essential knowledge and maintain social stability even during extended periods of environmental stress. This progression from simple to complex social organization wasn't inevitable or uniform. Many populations developed sophisticated local adaptations that proved highly effective under specific conditions but weren't transferable to other environments. Others created social innovations that were broadly applicable but required specific environmental conditions to function effectively. The populations that achieved permanent expansion were those that developed social technologies, combining broad applicability with environmental adaptability. The archaeological signature of these successful innovations appears in the cultural continuity maintained by expanding populations across diverse environments. Unlike earlier expansion attempts that show rapid cultural change as populations adapted to new conditions, successful expansion groups preserved core cultural elements while allowing peripheral innovations to vary with local circumstances. This cultural modularity combined stability with flexibility in ways that enabled rapid adaptation without losing essential social technologies. The demographic implications were profound. Populations that maintained cultural connections could draw on innovations developed elsewhere when facing local challenges. Communities that preserved core social institutions could adapt to new environments without losing the organizational capabilities necessary for demographic stability. Most importantly, groups that developed standardized cultural practices could maintain social cohesion across vast distances and diverse local conditions. Modern communities facing demographic challenges can learn from these ancient experiments in social organization. The most successful contemporary populations are often those that combine strong local identities with extensive external connections. They maintain cultural traditions that support demographic stability while remaining open to innovations developed elsewhere. They invest in social institutions that preserve essential knowledge while adapting to changing environmental conditions. The key insight from the archaeological record is that demographic sustainability requires active cultural management rather than passive biological processes. Communities that consciously develop and maintain social technologies, supporting population stability, are far more likely to survive environmental and social changes than those that rely purely on economic prosperity or technological superiority. The vanished migrations remind us that even the most capable populations can disappear if they fail to maintain the cultural foundations necessary for demographic viability. This perspective transforms how we think about contemporary challenges facing human communities around the world. Climate change, economic disruption, and social fragmentation all create demographic stresses similar to those that caused ancient populations to disappear. But communities that understand and apply the lessons from these early experiments in human survival have better chances of developing effective responses to contemporary challenges. The archaeological record provides a vast database of tested solutions to fundamental problems of human survival under changing conditions. Every failed migration represents valuable data about what doesn't work under specific circumstances. Every successful adaptation offers insights into social technologies that might be applicable to modern situations. Most importantly, the overall pattern reveals that human communities have remarkable capacity for developing innovative solutions to demographic challenges when they understand the underlying principles of social sustainability. The story of human expansion ultimately demonstrates that survival isn't just about individual capability or technological sophistication. It's about developing social organizations that can maintain viable communities under challenging conditions. The populations that vanished from the archaeological record weren't evolutionary failures. They were experiments that provided essential data for developing more effective survival strategies. Their legacy lives on in every human community that has learned to balance innovation with continuity, maintaining cultural identity while adapting to changing circumstances. Understanding this legacy provides both humility and hope for addressing contemporary challenges. Humility because it reminds us how contingent human survival really is, how easily successful communities can disappear if they fail to maintain the social foundations of demographic stability. Hope because it demonstrates that humans have remarkable capacity for developing cultural innovations that can overcome seemingly insurmountable challenges. The same species that produced so many failed migrations eventually developed the social technologies necessary for permanent global expansion. The lessons from these ancient experiments in human survival remain relevant for contemporary communities facing rapid environmental and social change. The archaeological record shows that the most resilient populations were those that maintained strong social institutions while remaining adaptable to new conditions. They preserved essential cultural knowledge while staying open to useful innovations. Most importantly, they understood that demographic sustainability requires active investment in social technologies that support community stability across generations. These insights suggest that contemporary communities concerned about long-term viability should focus not just on economic prosperity or technological advancement, but on developing and maintaining the social institutions necessary for demographic stability. The vanished migrations remind us that even the most successful populations can disappear if they fail to invest in the cultural foundations that make human communities sustainable over time. Their story continues to unfold as we face our own challenges of survival in an uncertain and rapidly changing world. The question we're left with is perhaps the most humbling of all. What made the difference between vanishing and surviving? The answer doesn't lie in some dramatic technological breakthrough or sudden evolutionary leap. It emerges slowly from the accumulated debris of countless failed attempts, like a pattern becoming visible only when you step back far enough to see the whole picture. By 60,000 years ago, something had shifted in the way human populations organized themselves. Not their anatomy, which remained essentially unchanged from their predecessors. Not their basic intelligence, which was indistinguishable from the groups that had disappeared from Greek caves and Arabian lake shores. What changed was their approach to the fundamental problem that had destroyed every previous expansion attempt: how to maintain viable communities in unfamiliar territories. The archaeological evidence for this shift appears gradually across African sites from this period. Stone tool assemblages become more standardized, suggesting shared learning systems that could preserve technical knowledge across generations and vast distances. Raw materials appear far from their geological sources, indicating trade networks that connected populations across ecological boundaries. Most tellingly, symbolic artifacts become both more common and more uniform, following patterns that appear simultaneously in sites separated by thousands of kilometers. These developments weren't random innovations scattered across the continent. They represent a systematic transformation in how human societies organized themselves and transmitted knowledge. Instead of each community developing unique solutions to local challenges, African populations were learning to share innovations across regional boundaries. This created something unprecedented in human evolution: a continental-scale knowledge base that could be accessed by any population connected to the network. The demographic implications were revolutionary. Small groups were no longer isolated islands, vulnerable to every environmental fluctuation or demographic accident. They became nodes in larger systems that could redistribute resources, absorb losses, and provide mutual support during crises. When local conditions deteriorated, communities could relocate without losing cultural continuity. When populations shrank below viable levels, they could merge with neighbours without abandoning essential knowledge systems. Archaeological sites from this period preserve evidence of these new survival strategies in action. Settlement patterns show greater flexibility, with locations being abandoned and reoccupied in response to environmental changes rather than being occupied continuously until collapse. Tool traditions demonstrate remarkable consistency across vast distances, suggesting populations that maintained cultural connections even when separated by difficult terrain. Most importantly, occupation continues without major interruptions, even during climatic stress periods that had caused earlier populations to disappear entirely. The contrast with contemporary sites outside Africa reveals the magnitude of this transformation. While African populations were developing increasingly sophisticated social technologies, the scattered sapiens groups in Europe and Asia continue to show the same patterns that had characterized earlier failed expansions. Small isolated communities with purely functional tool assemblages and no evidence of the cultural investments that might have supported long-term demographic stability. This difference illuminates what successful expansion actually required. Reaching new territories and establishing initial settlements was never the primary challenge. The real difficulty lay in maintaining viable populations under conditions that had repeatedly caused earlier communities to disappear. The African populations of this period were developing precisely the social technologies necessary for permanent settlement in unfamiliar environments. The process wasn't uniform across the continent. Different regions contributed different elements to this emerging cultural toolkit. Coastal populations developed maritime technologies and long-distance exchange networks that would prove crucial for later island colonization. Highland communities perfected cold weather adaptations and resource management strategies that would be essential for expansion into northern latitudes. Desert edge groups learn techniques for surviving extended dry periods and maintaining cultural continuity during environmental stress. But the most significant innovation was the development of cultural practices that could integrate these diverse adaptations into coherent survival systems. Instead of remaining isolated within their specific ecological niches, African communities learned to share innovations across environmental boundaries. A fishing technique developed along the coast could be adapted for use around inland lakes. A hunting strategy perfected in highland environments could be modified for savanna conditions. This cultural integration created something unprecedented, a knowledge base that transcended local environmental conditions. When groups finally began expanding out of Africa around 60,000 years ago, they weren't carrying just their own limited repertoire of local adaptations. They were carrying the accumulated wisdom of an entire continent, refined through millennia of experimentation and innovation. The genetic evidence supports this interpretation of successful expansion as a networked rather than isolated process. Unlike earlier expansion attempts that show severe bottleneck effects and rapid genetic drift, the populations that finally succeeded maintained surprisingly high levels of diversity across vast distances. This suggests communities that remained connected to their source populations and continued exchanging genetic material even after establishing themselves in distant territories. The archaeological signature of these maintained connections appears in the remarkable cultural continuity between African and non-African sites throughout the expansion period. Tool technologies that first appear in East African contexts quickly show up in Arabian assemblages, then in Indian sites, then throughout Southeast Asian locations. This isn't simple technological diffusion occurring over centuries or millennia. It's evidence of rapid communication and coordination between populations separated by thousands of kilometers. The speed of this cultural transmission suggests something revolutionary in human social organization. Earlier populations had certainly developed sophisticated local adaptations, but they lacked the social technologies necessary for sharing these innovations across continental distances. The successful expansion populations had somehow solved this fundamental problem of cultural scaling, developing communication systems that could preserve and disseminate knowledge across vast networks of connected communities. The solution appears to have involved creating standardized cultural practices that could be maintained across diverse environments while allowing local variations to develop in response to specific conditions. This cultural modularity combined stability with flexibility in ways that enabled rapid adaptation without losing the essential social technologies that made demographic survival possible. The implications extended far beyond simple knowledge sharing. Populations that maintained cultural connections could draw on innovations developed elsewhere when facing local challenges. Communities experiencing demographic stress could receive support from distant relatives. Most importantly, expanding groups could establish new settlements without losing access to the accumulated wisdom that had made their survival possible in the first place. This networking capability transformed the mathematics of expansion success. Instead of isolated pioneer groups struggling to establish themselves in hostile territories with only their own limited resources, expanding populations could draw on support systems that stretched back across continents. They weren't just colonizing new lands through individual heroism or superior technology. They were extending existing social systems into new environments through sophisticated organizational capabilities. The demographic advantages of this approach were immediately apparent in the archaeological record. Successful expansion sites show evidence of larger founding populations, more systematic resource exploitation, and greater cultural continuity over time than any previous expansion attempts. Occupation continues without major interruptions, even during environmental stress periods that had caused earlier populations to abandon their territories. Perhaps most remarkably, These expanding populations didn't simply abandon their African cultural practices when encountering new challenges. Instead, they adapted these practices to new circumstances while preserving their essential characteristics. This represents a sophisticated approach to cultural change that balanced innovation with continuity, allowing populations to remain flexible without losing the cultural identity that connected them to larger support networks. The social mechanisms that made this possible remain largely invisible in the archaeological record, but their effects are unmistakable. Successful expansion populations show consistent evidence of cultural practices that served no obvious survival function, but clearly required significant resource investments. Symbolic artifacts, ritual burials, decorative objects, standardized tool styles that exceeded functional requirements, all of these appear regularly in sites associated with permanent settlement. These cultural investments weren't frivolous additions to practical survival strategies. They represented fundamental changes in how human societies organized themselves and maintained cohesion under stress. Shared symbolic systems allowed large groups to coordinate activities without requiring constant face-to-face interaction. Standardized cultural practices enabled the preservation of essential knowledge in forms that could survive the loss of key individuals. Most importantly, these practices created psychological bonds that could maintain group loyalty and social cooperation even during extended periods of hardship. So here we are, bored people, at the end of a story that took 150,000 years to tell. The migrations that failed weren't really failures at all. They were experiments, lessons written in bone and stone, teaching our species how to survive in a world that didn't want us to succeed. Each vanished group, each abandoned cave, each silent hearth contributed something essential to the final attempt that worked. We exist today not because we were inevitable, but because we were persistent. Because somewhere in the accumulated wisdom of countless forgotten pioneers, our ancestors finally learned the secret that had eluded everyone before them. Survival isn't about being the strongest or the smartest. It's about staying connected, staying flexible, and never giving up on the idea that somewhere beyond the next ridge there might be home. Thanks for wandering through deep time with me. Until next time, stay curious.